What if I told you that two machine learning models can achieve almost the same accuracy on training data, but one performs amazingly on a real world data while the other completely fails? Why does this happen? The answer lies in two concepts every data scientist must understand: high bias and high variance. In today's lecture, we will break this concept down with simple examples, and then we will take our first step into most popular machine learning library in Python, that is Scikit-learn. Hello everyone, welcome back to the course. In the previous lecture, we learned about machine learning, its different types, training and testing data, and the complete machine learning workflow. Today, we will build on that foundation by understanding high bias, high variance, the bias-variance trade-off, and finally we will get introduced to Scikit-learn, the library we will use throughout this course. So let's get started. What is bias? Bias refers to the error caused because our model is too simple to understand the underlying pattern in the data. Imagine trying to fit a straight line through the data that actually followed a curved pattern. No matter how much data we provide, the model cannot capture the relationship. This problem is called as high bias. A high bias model underfits the data. The characteristics of it is model being too simple, performs poorly on training data and testing data as well, unable to learn the actual pattern. Let's look at the opposite problem now. So what is a variance? Suppose our model memorizes every single training example, including noise and random fluctuation. It performs extremely well on the training data but struggles on new unseen data. This is called as high variance. Characteristics of high variance are model being too complex, very low training error, high testing error, learns noises instead of actual pattern, causing overfit. High bias versus variance. Think of it like preparing for an exam. A student who studies only 2 pages and ignores everything else is like a high bias model. Another student memorizes every question, every example, and every tiny detail without understanding the concept. That student resembles a high variance model. Our goal is to become a third student, someone who understands the concept well enough to solve new questions. Similarly, in machine learning, we want to balance between bias and variance. This balance is known as bias-variance trade-off. So what is a bias-variance trade-off? Our goal is not to make bias 0 or variance 0. Instead, we are trying to find a sweet spot where the model generalizes well to the unseen data. A good machine learning model has low enough bias to learn patterns, low enough variance so it doesn't memorize this noise. Finding this bias is one of the biggest goals in the machine learning. Now, let's look at the Scikit-learn library. We will understand how machine learning model behaves. And let's understand one of the most important Python library for machine learning. Scikit-learn is an open source Python library that provides ready to use implementation of machine learning algorithm. Instead of writing algorithms from scratch, we simply import them and train the model in a few lines of code. It contains classification algorithm, regression algorithm, clustering, data utilities, model evaluation tools, data pre-processing techniques. So this is the library we will use throughout the course. Now practical. We will be loading a data set and find important features in it. So for that, we should understand some key terms like what is a data set? Data set is simply a collection of observations. Each observation contains an input feature x and a target variable y. The machine learning model learns the relationship between x and y. Now, important components of data sets are data, which contains all the input feature. Row represents observation. Column represents feature. Target contains the correct output labels. These are the values our model tries to predict. Feature name of each input column. This helps us understand what every feature represents. Target name. If the problem is classification, this contains the name of each class. DSIR, a detailed description of the dataset. It explains where the dataset comes from, what each feature means, and the other useful information. So in this lecture, we understood the concept of high bias and high variance and learned why balancing them is important and got introduced to the Scikit-learn library. We have also explored the structure of machine learning dataset. Now we will practically see how to implement the code in Visual Studio. So this is the practical part of the video in which we will be loading a dataset. By using various features we saw just now theoretically. The first one will be the describe feature, which we will describe the dataset. So in order to load the dataset, we use this line. So from sklearn.dataset import load iris. There are other datasets like breast cancer, diabetes, etc. But we will be focusing on loading the iris dataset. We have created an iris variable in which the dataset is being stored, and now we are printing iris.describe, which will give us the output of a full detailed information of what this dataset contains. It takes a little time to load inside the terminal because it is a huge information. We will go through what the information is. So zooming the terminal window, we can see all the information. So this is the iris plant data set where we identify plant species based on features. It has 150 rows and 4 input feature column like sepal length, sepal width, petal length, petal width, and classes, that is our target variables setosa, vesicular, and virginica. This is the main summary statistic of each of the features like minimum, maximum value, mean, and standard deviation, and the other miscellaneous information which we don't care that much. Going back with the code, now we will try to identify the input, that is the y variables. This will be our feature columns. So printing iris dot data. So data contain all the feature values of the table. I have commented the description out since it will take again a larger time to load, and so to it load faster, I just rerun the terminal. Now these will be our training, not training rows, but actually these are the input features, like we have also printed the shape of the data set, which will be equal to 150 by 4. That means 150 rows are there and 4 columns are there. So 4 columns means sepal length, sepal width, petal length and petal width, and like one row contain the units for each of that column. Now we will print target variable, which is our y, that will give an output in 0, 1, 2 based on what kind of plant species it is, which we'll understand a little later when we have when we will print about the target name and feature names. So 0, 1, 2 represents the type of plant based on its characteristics, of course. Like the last row belongs to second class. Second class is of West Virginica plant species. You'll understand it more when we will print the feature name as well as the target name. Printing iris dot feature underscore names. And also at the same time loading target names. Corrected the mistake. After running it in terminal, you will have the complete story of the output. Since it takes a little time, so we have to wait for that. So the first, the last second row is our, so the last row is our target names, and the last third row is about our feature names: sepal length, sepal width, petal width, and class 0 means setosa.